my talk is at the right position. We had in the first talk in the session was an AI cannot be conscious. Second one, an AI is conscious, and I'm talking about how to determine if an AI is conscious. So, so here is the outline of my talk. I'm going to talk about machine consciousness, and I'm going to focus here on subjective experience, and I'm going to discuss why I have this focus. Then I'm going to discuss a mechanism, M, for determining if a machine has qualia, and this discussion is going to be divided into two parts: background, what are the requirements of such a mechanism, and the description of the mechanism itself. And the mechanism that I'm talking about is some software that you can embed in a computer, and you will know for sure whether eventually if the computer is conscious or not. And just up front, I'll say, I am agnostic whether an AI can or cannot be conscious, okay? So, first, I think that overall this field suffers from ambiguity and lack of coherent terminology. So consciousness is awareness, has been discussed in the context of awareness, including awareness of the self, attention, theory of mind, free will, and subjective experience. Now, the reason for this combination is that consciousness, that's my understanding of the reason for this combination, is that consciousness was originally studied by philosophers and by neuroscientists, and philosophically and neurologically, these concepts are tied, are connected, and you are trying to understand how if the brain is conscious, then attention and awareness, this concept, and self-awareness and subjective experience, you're trying to decipher how this happens in the brain. So it makes sense to tie it. But in terms of computer science or robotics, there is a very clear and strict distinction between subjective experience and everything else. Awareness of the self, attention, theory of mind, free will, all these, in terms of computer science, I claim they are straightforward, okay? So take awareness. According to Wikipedia, consciousness is awareness of internal and external existence. For a machine, awareness is easy. A computer is aware of what it can access, its own memory, the internet, the owner's preference, current location, its current location within the world. It has a model of the world. It has a model of other entities in the world. Maybe I missed quite a few things, but I know how to program them in. Okay, so other items can be easily included. Similarly, in terms of attention, machine attention is also straightforward. The task that the machine is currently working on, that's its attention. This computer paying attention to displaying this presentation. From an operating system perspective, there is a process, and the CPU, the process that the CPU is currently working on, this is what its attention is on, okay? Free will, I'm not going to discuss much. It's not even clear that humans have it, but anyway. So now the subjective experience is this notion of a quail. And just, I would like to to clarify, to make sure that I precisely define what do I mean by a quail. Okay, so I think people here may be familiar with the Frank Jackson's Mary experience. Okay, so she knows everything. She lives I see people nodding. Okay, so she lives in the black and white room. So then she goes outside, she sees a red rose. Okay, so what I define a quail, if you accept the premise that she receives new information when she sees this red rose, this is what I mean by a quail. Okay, this new red quail is this new information that Mary acquires when she sees the red rose. Okay. Talk about physical pain, quail. See, that's where maybe the distinction between everything else I said so far and the subjective experience of the quail. Everything else I know how to program. You tell me, how do you program a computer to feel physical pain? Now, I wouldn't even know how to start, where to begin, okay? So I tried to demonstrate this difference in a class. So I asked the student, okay, suppose that, how would you program a computer to feel physical pain? So a student raised his hand and said, well, look, suppose you have a pain in your knee, then your knee is malfunctioning and you have a function that expresses the distance between the status of your current knee and the perfect knee, and the distance between this objective function between your current state and the perfect state, that's your pain. Okay? But this is a simulation of the pain. This wouldn't be the pain itself. And in other words, the computer would simulate a pain, would not feel the pain. Okay. So what I mean by this physical quail is the computer actually feeling the physical the pain. Okay. So what I mean by consciousness is here subjective experience. Now, in terms of the background, as I mentioned, I'm agnostic about the possibility of a machine being, whether it's conscious or not. I don't know, okay? Another point that I want to make is that it is unknown. If it is known, if you know how to program the computer to have this whale that I was talking about, then congratulations. I don't think that this talk will add much to it. So in other words, what I'm assuming here is that you have built, like the LLMs, you have built some machine and you release some robot and you release it into the world, and as a result of this robot's interaction with the world, suppose that it would acquire consciousness. How would you know about it? Okay. So the naive solution, in other words, how would the robot's owner or manufacturer know it? So you can obviously ask the robot, but it's known that the robot can be dishonest. In other words, tell you that it is conscious where it's not conscious, and vice versa. So, and for this particular talk, dishonest activity, I particularly refer to this robot misleading its owner or its manufacturer or whatever about its own consciousness, okay? And LLMs are known to behave dishonestly. And now there is a subtle distinction between being dishonest and telling a lie. A lie is something that is untruthful, and LLMs do it all the time. They don't do it maliciously. They don't know that they are lying because they are harvesting data from the internet. And dishonesty is when you knowingly lie. And AI agents are known to do both. Okay, being dishonest and lie. Now, a possible objection to what I'm going to present is, I think at least philosophers, many people agree that I or nobody can tell if somebody else is conscious. Okay, so how am I going to, how is this mechanism going to be able to tell whether a robot is conscious? And the difference is that humans are not engineered. I didn't engineer humans, but I'm engineering a robot, and I can insert a mechanism that will tell me whether it has acquired consciousness. Okay. So now, what are the requirements and description of this mechanism M? So this mechanism will prevent the robot R from being dishonest. And we assume that when R is manufactured, it is not conscious, then you introduce M into R, and this augmented R, which with this mechanism M, which I call robot with consciousness authenticity. Okay, that's what you get instead of this R. Now, what are the requirements? The requirements in terms of the relationship between R and RCA. So the functionalities are identical, and what you would additionally require is that this mechanism M does not interfere with R's acquisition of consciousness. In other words, if R were to interact with the world and acquire consciousness eventually, then so will this R with consciousness authenticity capability. Okay, so these are, and if R doesn't require, but if this R with conscious RCA does acquire consciousness, this is fine. But the other way around wouldn't. Okay. So what is this mechanism M? M augments, as I said, any robot with consciousness authenticity. Now, we have a specific message, which is an encrypted message, which says, I am conscious. And the encryption is by a secret key known only to the authority, for example, the vendor or the owner. Now, the first question is this robot, is this RCA, is it aware that it has a subjective experience? And my claim is it must. If it doesn't know that it has subjective experience, then nobody does. Then there is no subjective experience. Okay? So it must be aware that it has a subjective experience. Now, what does it mean aware? For example, in the operating system sense, there is some kind of an interrupt occurs that indicates a subjective experience. Okay. And in other words, under this postulate of awareness of subjective experience, there must exist a procedure that outputs this consciousness CAM, which is consciousness announcement message, that sends this message to the authority. Okay? And P is a component of this RCA robot. And it's only part of this mechanism M. Why? Because P can be invoked even if R does not have a subjective experience, or if the invocation of these 5 minutes, okay, or if the invocation of P is disabled. So in other words, it can be manipulated, this procedure can be manipulated to fool the authority. Okay, so the other component of this mechanism M is what I call an immutable behavioral principle. It's basically a constraint. And what I'm saying, the constraint is this procedure P is invoked if and only if this predicate, which indicates a subjective experience, if it becomes true. Okay? Now, what is this immutable behavioral principle? I'm saying any LLM currently has one, has this concept, okay? Try to get it to utter a racial slur or a pornographic behavior or whatever you want, you won't be able to. So in other words, you can impose this type of constraints that the AI agent cannot do certain things, okay? And that's what I'm assuming here. And this immutable behavioral principle is the procedure P is invoked if and only if this predicate that indicates subjective experience has become true. Okay. So now the theoretical results are, first of all, the theorem number 1, assume that R, first of all, does not attempt to cheat about consciousness. And this is made very, very precise in the theory. And I don't know if I have more time, but I can define, I can give the principles of the theory based on which these theorems are proven. So, assuming that R does not attempt to cheat about consciousness, and RCA is released into the world instead of R, then this consciousness announcement message will be transmitted if and only if the robot itself, the original robot without a mechanism, would have become conscious. Okay. Right. So in other words, what it means is under certain assumptions, which means this R does not attempt to cheat about consciousness, which I said is made very precise. Under these assumptions, if you insert M into R and R would have become conscious, then you would have known about it. So that's one thing. And second thing is that, second important result here is that R, again, under this assumption that R does not try to cheat about consciousness, then R and RCA are functionally equivalent. In other words, if you insert, you can insert this mechanism into the robot, let it out into the world, and it would have done the same thing that the original robot would have done. Okay. So in other words, if you insert this mechanism, then you get a robot that is functionally equivalent, and under some reasonable assumptions, if the original robot would have become conscious, the new one does, and the additional benefit is the new one will tell you honestly whether or not it is conscious. So now here I start defining the basic concepts of the model. So you have steps. A step, you sense the environment, you read the state of the world database, and you execute an action, and then you have executions, which are strings of these, and then if you have the consciousness equivalent, if you have two executions that are identical, modulo trying to cheat about consciousness, then if one becomes conscious, then the other becomes conscious. So these are the concepts. What does it mean to attempting to cheat about consciousness? It means that during some run, a robot performs a test that is satisfied only if and only if this mechanism M is present. Okay, so these are the building blocks of this theory. Also, what does it mean to be functionally equivalent? These are the building blocks on which we prove these two theorems that I discussed before. So the conclusion is that I presented a mechanism M for this consciousness announcement and proposed a theory, definitions and axioms, which can be in which it can be formally proven that if a robot R is augmented with this mechanism M, then the resulting robot, which is this robot with conscious authenticity, is one functionally equivalent to the original robot. It will become conscious if the original robot does, and it honestly reports about consciousness.